Before you begin listening and watching this video, what you'll need to do is go into Module 1 of the course and make a copy of a lesson in metrics, and then after you have that, you can come back with me. Okay. What we're working with, obviously, is we're doing some metrics. And if you'll notice, what we have here is conversions. First one you're seeing is a conversion from Fahrenheit, degrees Fahrenheit, and then also you see into Celsius. And the second one, we're going to be converting degrees Celsius into degrees Fahrenheit. So we're just going to assign arbitrarily, let's say that we're working with on degrees Fahrenheit, let's say that's a 72. We'll try to make this pretty easy. 72 degrees Fahrenheit, so we're going to subtract 32 off of that. And then we're going to multiply that by 0.555, and that'll give us the answer we're looking for in degrees Celsius. Okay, so let's see. We've got 40 times 0.555. Again, that's going to give us our degrees Celsius. So now, let's see, 40 times 0.555, we'll put that into the handy calculator that we happen to be holding here, and that says a 22.2, and that is what we get as an answer for degrees Celsius. So always solve what you have in parentheses first, and then do the multiplication after that, and you can't go wrong with it. You will end up with the correct answer. You do have to know obviously the formula in order to make that conversion. All right, so that's Fahrenheit Celsius. Let's move over to Celsius Fahrenheit. In United States, of course, we're using degrees Fahrenheit. It's like, we know what 72 degrees Fahrenheit is, and 32 degrees Fahrenheit is freezing. So that's what we're most accustomed to using. But in other countries, in fact, in all other countries, they actually use degrees Celsius. So if you want to travel over to Italy, you're going to be looking at a sign that tells you what the temperature is in degrees Celsius, and you might want to be able to convert that Fahrenheit, so you'll have a better idea of actually what that would be if you were in America. But you would be lucky because you would be in Italy, and that would be great. You'd probably like that quite a bit. So let's say that, let's just arbitrarily, this will make this easy on ourselves. Let's say that we're going to call it 100 degrees, we'll put 100 in there, degrees Celsius. And obviously we're going to solve that first before we add 32 to that, and then that'll give us degrees Fahrenheit. All right, so 1.8 times 100, I believe that's going to be 180, if I get my pen to cooperate, and that is in degrees Celsius, plus 32, and that'll give me degrees Fahrenheit, and what we got is 180 plus 32. If you add that together, you're working with 212, and that is degrees Fahrenheit. 212 is what the boiling point of water is on the Fahrenheit scale. Most people don't actually know that number for some reason. They tend to not learn that. I don't actually know why, but anyway, it's kind of an unusual number. You just have to put it in your head. 212 degrees Fahrenheit, that's a boiling point of water. There you have it. Anyway, so we've done from Fahrenheit to Celsius, from Celsius to Fahrenheit. As long as you've got your formulas there, you're in good shape. I don't see any problem there. Okay, we'll move on from that. And from there, let's go to, let's say, if you're looking at your handout there, we're going to use from the first table that you see there, close to the top of that handout. You'll see 1 foot equals 12 inches, 1 yard is 3 feet. Notice the 1 mile equals 5,280 feet. That's not a number that most people just commonly have in their head, but it's something that you probably should commit to memory. Now, I'll use that. We'll use a system which is called dimensional analysis, and I'll write that on the board. are not familiar with it, let's see, that's not spelled correctly, but I think I can get to it. All right, that again, dimensional analysis. And the beautiful thing about this is it works always exactly the same way. And I love things that are like that because you always follow the same system. And if you follow it the same way every time, you know that you're going to get the correct answer every time. There's no way to mess it up, as long as you follow the system. Okay, so the system would be, let's do something, let's say that, I don't know, let's say that we've got, we're driving from Tucson to headed into Mexico. They're at the border, and let's say that let's say we're at the border and we're heading to the beach, and it tells you that it is. They tell you there that. It is 80 miles. All right. So if we wanted to convert that into feet, which I don't guess most people would care, but let's say if we did want to be able to do that, we certainly need to know that 1 mile equals 5,280 feet. All right. Otherwise, without that information, there's no way you could do this. All right. So the way that this dimensional analysis works, you take the information that you have, which we said was 80 miles. That's what we've been given. And the task here is to convert that into feet. So you write what you've been given, which is 80 miles. And in order to convert that to feet, you will always put a multiplication sign. You will always open and close parentheses and make this a fraction. Okay, now the unit that you have in this case is miles. You want to eliminate that unit. Obviously, we want our answer to be in feet. We do not want it to be in miles. So we will put miles as a denominator. So we put that on the bottom of the division sign. All right. And the unit we want to convert to, we're going to put as a numerator. So we're going to put that on top of the division line. So we know that there are 5,280 feet in 1 mile. All right, so I wanted to move from mile. I wanted to convert that into feet. So I've been given mile. Obviously, I want to go to feet. So again, dimensional analysis, put a multiplication sign, open and close parentheses, make it a fraction, put the unit you're trying to eliminate on bottom as a denominator, and the unit you're trying to convert to on top, which would be the numerator. Okay, and any number that you're given is actually over 1. So I'm going to put 80 miles over 1. Okay, so at this point, you'll notice that we can cancel out the mile. So miles have canceled out. So then we just have to multiply. So now it looks like we're just multiplying 80 times 5,280 feet. And this is going to give us a pretty ugly answer, but it's just a number is all it is. It's just a number. So it's 422,400 feet. All right. So I know it's a pretty ugly number, but here again, long you got a calculator, what's it matter? That's 422,400 feet. Not that you probably want to really remember that. I know I wouldn't want to remember that, but anyway, if you were given that task, then there you have it. That would give you the answer. Let's do some more of these. Let's do some more conversions. If we're going to be converting, say, like from English to English, which is obviously what we're doing right here, then, of course, we're going to be using this dimensional analysis system. And it works the same way every time. But let's say that if you wanted to convert from metric to English or from English to metric, and if you look at the table on the bottom of your first page, you have 1 meter equals 39.37 inches, 1 kilometer is 2.2 pounds, 1 liter is 1.06 quart, 1 inch is 2.54 centimeters, and so forth. All right, so let's just say that we have, again, we're going to take a number in unit that you're given. I mean, it's going to be a problem, obviously. You're going to have to be tested over this. So you just take what you're given. Let's say that we have, I don't know. Let's say that we have 0.5 inches. Let's just make this 0.5 inches. All right. And we want to know what the answer is in centimeters. Okay. So what is my answer in centimeters? So again, on dimensional analysis, it works every way, every time, exactly the same way. It is beautiful. I love this. Okay, so 0.5 inches, you put a multiplication sign, write what you're given, put a multiplication sign, you know the rest of it, open the parentheses, close parentheses, make it a fraction, put in your division. Okay, so the unit we're trying to eliminate is going to be inches. I'm going to put that as my denominator. Like I said, it works the same way every time. Whatever we're converting to, I'm going to put as my numerator here on top, and then I make those two equal. Well, it tells me on this handout that 1 inch is 2.54 centimeters. All right, so I fill that in. So again, this number that I've got, which is 0.5 inches, that's really over 1. So what's going to happen is you're going to eliminate inches, which is what we wanted to do. And now I've got 0.5 times 2.54 centimeters. And all we got to do is plug that into a computer, a calculator, and then or your phone. And then what you're going to get as an answer, you're going to get 1.27 centimeters. And you did that correctly. And it works the same way every time. You cannot mess these up. I don't know how you can mess these up. Okay, let's do another one of those. Let's just try that again. Just a little bit more practice. Practice is good. And if you need more practice, I do have and can get you some extra practice sheets if you want those. And I think you all understand that you can just go to Google and hit metric practice problems, and you can probably do those the rest of your life until the day you're dead. But you probably have other things you'd rather be doing. Okay, so we just need to understand this well enough to get past that test. All right, so let's look again at that table. And you see where it says 1 mile is 1.609 kilometers. Okay, this is where I was actually going when I was talking about going from the border to the beach. So you're at the border at America and Mexico, and you're going to the beach right out of Tucson. Okay, and once you cross that border, it tells you that it is 80 kilometers to the beach. Well, you're probably pretty interested in, I want to know how many miles that is to the beach, because you don't really understand a kilometer well enough. At least most of us don't. So let's take what we're given, in this case 80 kilometers, and we're going to convert that into miles. So 80 kilometers, put a multiplication sign, open and close your parentheses, make it a fraction here. We're going to put kilometer as a denominator, and we're going to make a mile as a numerator. And we already know that 1 mile is 1.609 kilometer. Okay, so again, your kilometer is canceled, and now I have 80 mile. If you multiply across, you're looking at 80 mile divided by 1.609. So if you put that into your calculator, what you end up getting out of that is you're looking at 47.33 miles. I always go to the second significant digit. That was actually 47.337 whatever. It went on quite a distance after that. But I go to the second significant digit, and that I stop right there. There's no point in writing all those numbers. And again, you'll see that I've just followed the same system, and it works beautifully every time. Put whatever unit you're trying to eliminate as a denominator on the bottom of the division, and whichever unit you're trying to convert to on the top as a numerator on that division, and make those two equivalent. So in this case, 1 mile is 1.609 kilometer. And if you're doing that, all you've got to do is multiply and divide it out, and you will have your answer. So it's very, the system will work, and it works for everybody. And in this way, then everyone will be able to, with a little bit of practice, it does take practice, certainly. But with a little bit of practice, you're not going to have any problem doing anything that will throw your direction that you will not be able to do. You will be successful at this. Okay, now there's one other thing that we do want to cover here. Let's say that I'm converting from metrics to metrics. So I'm just going to put up here to metric, or vice versa. It just doesn't really matter there, does it? All right, so metric to metric. Okay, in this case, there's several ways you could use the analysis to do a metric to metric. Many of you know how to do that. I know in chemistry they show another method of doing this. What I find is the easiest way to do this, and once you get accustomed to it, you can even do it in your head. That would take quite a bit of you have to get really accustomed to doing these before you probably do it in your head, but it doesn't take that long. But I use a number line, and you probably have not used a number line since, I don't know, whatever. It's probably the 3rd grade, somewhere in there. They stopped doing that. But it does work, and I find that anyone can use it, and it's a really fast, easy way to do these problems. Okay, but that's if you're going from metric to metric. Remember, if it's English to English, you need to use dimensional analysis. If it's English to metric or metric to English, you use dimensional analysis. But if you're going metric to metric, I find this to be a quick, easy way to make a conversion. All right, so I've drawn a line, and of course I've sectioned this off. And at that point, I'm going to put meter, liter, and gram on that. And then to the left of that, I'm going to draw 3 lines, and I'm going to put a K for kilo, K-I-L-O, and then an H for hecto, and then a DA for deca. Now, kilo means 1,000, so above that I'll write 1,000. Hecto means 100, so I'll put 100 above that. And deca means 10, so I'll put 10. So if you want to say kilometer or kilometer, that's 1,000 meters. If you want to say a hectometer, that's 100 meters. If you want to say a hectoliter, that's 100 liters. If you want to say a hectogram, that would be 100 grams. If you said a decameter, that would be 10 meters. A decaliter, 10 liters, obviously, and decagram, same thing, 10 grams. All right, now to the right of the meter, liter, gram, which is actually 1, then I'm going to have a deca, just a D, and that means 1 over 10, or another way to do that is 0.1, or another way to write that will be 10 to the minus 1. All right, so, and then I'm going to put centa. Centa is a 0.01, which is actually 10 to the minus 2. All right. And then I'm going to put milli, which is an M. And if you'll notice, the symbol for milli which is milli, is exactly the same as the symbol for meter. But if you just have one M, that is meter. If you have two M's, it's millimeters. So you'll never be confused as long as you're working with one or you're working with two. One is meter, two obviously is millimeter. On the milli, that would be that's 1/1000th of a meter. Okay, so this would be 0.001, which is 10 to the minus 3. All right, so, and then I'm going to put two lines. So that line is 10 to the minus 4, and I don't know a prefix on that. I'm not saying there isn't a prefix on that, but I have never seen it written anywhere in any book. I've been teaching biology and metrics for 35. This was going on 36 years. So if there was one out there, you'd think I'd seen it at this point in time. But you know, if you know it, let me know, because I don't know it. Anyway, so that's 10 to the minus 4. I don't know a prefix to write there, or 10 to the minus 5. Don't know that. But I can put at 10 to the minus 6 at this juncture, I can put, let's see, that would be micro. And the micro is like a symbol of a U, except you put a tail on the front of it, just a little bit of a tail. Now, of course, on a computer, we can't type that in. There is no symbol for micro, so we have to just write a U. We have to type in a U. And that's, of course, what we use for micro is a U. It's not totally accurate, but it does work. It's best we can do. That's all you can do. All right, so that's 10 to the minus 6 is micro. And you can have a microliter, microgram, micrometer, or micrometer, as they would say. Okay, and then I'm going to have a 10 to the minus 7. Again, I don't know a prefix on that. And then I'm going to have a 10 to the minus 8. I don't know a prefix on that. And then I'm going to have a 10 to the minus 9. And this is what we call a nano, incredibly small. The symbol on that is just an N on that. So that's 10 to the minus 9, which is actually 1 over a billion. That's 1/1,000,000,000th. Micro, if I back that up, the U, that's 1 over a million. But nano is 1 over a billion, like a nanometer. This would be something that would be used to measure the size of a virus. They're incredibly tiny, so nanometers. You may have heard of nanobots. They're building robots that are the size of nanometers, and there's a lot of research being done on that, and it holds there's a lot of hope in that. Be able to insert something like that into a human being and go in there and clear up an artery that's blocked, a little robot that's so tiny that they can clear up an artery blockage, or any number of things they could do with that, you know, if they programmed the nanobot to do that. So a lot of hope there. A lot of good things being done. As long as we continue to fund our research, and hopefully they will continue to do that. Okay, so now at the 10 to the minus 10 spot, I'm going to put an A, and I'm going to put a little degree on top of that. What that stands for, and I'll write this up here, the A with the degree, this is not a unit. This is actually, a prefix. It's actually a unit. That is not a prefix. It is a unit. That stands for angstrom, A-N-G-S-T-R-O-M, angstrom. That's kind of like meter, liter, gram. Those are all units. Kilo, or a hecto, or a deca, or a milli, or a micro, those are all prefixes. But angstrom is actually a unit, and it's 10 to the minus 10 meters. So that's what that stands for. So it stands for 1/10,000,000,000th of a meter. So that's incredibly tiny. Now, I do know, if you'll notice, your number line, just found on, this would be page 2, is larger and smaller than, if you'll notice what I have here on the board. Well, this is what I require students know. So this is what a person should know. But the number line can be larger and smaller. Metrics is more involved than just what I have right here. But we're not at a graduate school level just yet. Hopefully you'll get there. And this is just the road in that direction. Okay, so let's just take any number and let's make a metric to metric conversion. So I'm just going to arbitrarily say 0.00732, and again, I'm just making something up here out of my head. It doesn't really matter. And let's say that's a hectogram, HG, hectogram, and let's convert that puppy into, let's say, a milligram. So there we have it. Okay, so the way that this is going to work, you're going to take, and I'm going to use a different color because I can. All right. So, the decimal that you have in this 0.00732 hectogram, that decimal is sitting on the H, the hecto. Right now, you're not having to place it there. It's already there. All right, so I'm going to put a dot right there because that's where it's sitting. Now, where I want to move it is to milli. Okay, but I want to count the number of spaces that I move, and I want to make certain I know what direction I'm moving in. Well, if I'm at hecto and I'm moving down to milli, I'm going from left to right. Now, that's incredibly important because if you don't know which direction you're moving, you're going to miss your problem, and you will miss every problem. So that is incredibly important. So the decimal is already, the decimal that I have in this number is sitting on H because it says hectogram, so it's sitting on H. So I'm going to move that decimal, and we'll count spaces that we're moving, and I'm moving it 1, 2, 3, 4, 5 places. Again, make sure you know what direction you're moving. I'm going from left to right, and I'm moving it 5 places. So the decimal that I have in this number, 0.00732, I want to move that decimal 5. Okay, I had to count it again. 5 places, and I'm going to move it to the right. If you move it to the left, you miss the problem. So I'm going to the right. So here we go. 1, 2, 3, 4, 5. Decimal right there. So this is actually 732 milligrams. And we've made our conversion. Okay. Let's do a few more of these. As you can see, these are once you get used to this, it takes practice, always. You just practice it until you have it down. There's plenty of time between now and test time in order to practice all of this. Let's go with blue. I like blue. It's good. Any color. All right. We can do green, purple. We got colors here. All right. So let's say that we have, I'm going to throw just a number out of my head, 1,471. I'm using sevens today, I guess. I'm liking those. 0.03, again, why not? And let's say that is in micro, I don't remember what I used before. Let's just say liters, micro liters. You know, of all the units, liter is supposed to be capitalized. You know, meter, liter, and gram. Meter is not capitalized. Gram is not capitalized. Liter is supposed to be capitalized, but it's very common, and it's even written in books as a small l. Now, because I know it's supposed to be capitalized, I do capitalize it. That's just me. That's just me. So anyway, I'll usually use a capital L. Maybe someday I'll fall off that wagon and start using a small l. But to this day, nope, still using the capital L. All right, so let's convert that. Let's say that equals, I don't know, what do you want to do? We're going from micro, let's move it to just milli. So micro to milliliters, why not? Okay, again, that decimal that we have in this number, is sitting on micro. I'm not having to place that decimal there. It's already there. So we're not counting that spot. Do not count that spot. You'll miss every problem. It's already there. And I'm going to move it down to milli right here. So I'm going to count the number of places, and I'm also going to recognize which direction I'm moving that decimal. So I'm going to take this, and I'm moving it 1, 2, 3 places, and I just moved it from right to left. So if I take that decimal, I'm going to move it 1, 2, 3 places. So now I'm working with 1.47 milliliters. Notice I stopped at the second significant digit. I just dropped off the 103. Those are not that significant. So 1.47 milliliters. Make sure you know where the decimal begins, where it ends up. Count your spaces, and make sure you know what direction you're moving. You cannot miss a problem. You will not miss a problem. You we'll get every one of these correct on a test, and that will be good because by the end of the semester, I'm thinking there will be a few of you, if not more than a few, who will really want some good grades. I don't know. I'm trying to come up with a good color. Let's look at that one looks, I don't know. Let's go kind of purplish. Well, I like that. Works for me. Okay, we'll do one more because these get a little redundant after a while. Let's go with 0.00074. I'd use a 7 again. 742. I don't know. Maybe I'm using the same numbers every time. Who knows? Let's make that a kilometer. Why not? km equals, let's just take that over to, well, I don't like that line. Let's do that again. Okay, let's go back. Here we go. All right, let's see if I can draw a straight line. Okay, so let's go from kilometer. Let's take that puppy to micrometer. So micro is a U with the tail on the front of it if you're writing it, which we can do because we're writing it, and that's a nanometer. I mean micrometer. We're at micrometers. Okay, so my decimal is sitting on K right here. I don't have to put it there. It's already there. Already there. All I'm doing is moving my decimal. Make sure you know what direction you're moving it. It's sitting there. I'm not counting that spot. It's already there. So I'm counting the space. 3, 4, 5, 6, 7, 8, 9 places, and I am going from left to right. 9 places. This is going to get big. All right. 1, 2, 3, 4, 5, 6. I'm going to have to add 3 more. I have to add 3 zeros. So that'd be 7, 4, 2 with 3 zeros. That's decimal would be at the end of that. So that's just 742,000. There we have it. So I hope you'll find this helpful as you go through. Now we even have office hours that are online. We're required to keep 2 of those per week. So, and we do have a tutor, and I haven't identified who that is just yet, but we will have a tutor available, and so, and we will make sure you get the name and the tutor's hours and where that individual will be available for tutoring, and you got all the help you would ever want. I can promise you that. So again, good luck with this. Practice it, and